Hello, so in this video we will talk about vector products, their related identities and related examples. So the definition, we start as usual with the definition. So if we have a vector given by the components a1, a2 and a3 in x, y and z direction. So I, j and k are unit vectors. Okay, so I, or you can have them underlined the way you want. So the cross product or the vector product is defined by this determinant. Okay. Now note that determinant by definition is only for scalars, but just for notation, we write it like this, so that if we expand it by the first row, we'll get this expansion. So for I, we have only this matrix, and the determinant of this is a2b3 minus a3b2, and so on. Okay, and that's why for j we have a negative, because this is second column and first row, and 2 plus 1 is 3, which is odd. Okay, so then now note that a cross b and b cross a are additive inverses of each other. Why? So since interchanging rows in a determinant creates its additive inverse. Okay, okay, which also means that if something and its additive inverse are so if I say a cross a, this is equal to negative of a cross a, which means I'm just flipping this a with this one. So this means what? If something is a negative inverse of additive inverse of itself, so this means a cross a, this is equal to the zero vector. Now this can also be seen that if you have the same row here, the same row repeated twice, you get the zero denominator. Okay. Okay, so we'll keep this definition in mind and we will use it in a bit. Okay, now we start with the triple product. So triple product is given by the cross product of the first two vectors and dot with and the scalar product of the first the scalar product of the cross product of the first two vectors and the third vector. So this is also given by this determinant. Okay, now let's prove this. So now we have a cross b. We know that this is equal to this guy. So I will say we have a2 b3 minus a3 b2 I minus a1 b3 minus a3 b1 j plus a1 b2 a1 b2 minus a2 b1 k, and then dot product of this guy with c1i plus c2k sorry c2j plus sorry yeah plus c3k. Okay, now if we take the dot product, this guy will multiplied by this guy, this will get multiplied by this guy, and this guy will get multiplied by this guy. So it's obvious that once we do that, I times I is 1. So all we have to do is this will be replaced by C1, this will be replaced by C2, and this will be replaced by C3, and this is exactly the expansion of this determinant here. Okay, so what does it mean? The important thing is that now note that if C is spanned by A and B, if C is spanned by A and B, it means that this row is some linear combination of A and B. So which means If this is a linear combination of A and B, this means the determinant will be 0. So this means A cross B C is equal to 0. Okay. So this also means that A cross B and C are orthogonal. Okay. So this also means that A cross B and any vector spanned by A and B is are orthogonal. And this means that A cross B is orthogonal to the plane spanned by A. Okay, so this is what I have written here. So we know that if a row and a determinant is a linear combination of the remaining rows, the determinant is 0. This means that any point in the plane spanned by vector A and B will be orthogonal to A and B, which means that A cross B is orthogonal to the plane spanned by A and B. Okay, all right. So here there's one more thing I want to mention, which is the right hand rule. So if you have A like this and B like this, so then what you do is you curve your fingers from A to B and your C will be the thumb. Okay, so you curve it like this and your T is the thumb. Okay, so this is not C, this is A cross B. Sorry, your A cross B is given by the thumb. Okay, so this is about the direction of A and B. Now we come to the how do we find the length of A cross B. Okay, the idea is that this is the area of the parallelogram spanned by the vectors A and B. Okay, so then what is A cross B? So A2 B3 minus A3 B2 I squared plus A1 B3 minus A3 B1 squared plus A1 B2 minus A2 B1 squared. Okay, so if we rearrange it using some simple algebra, simple but long algebra, so I can write it as this. B2 squared plus B3 squared minus, and then minus I can write A1 B1 plus A2 B2 plus A3 B3 squared. Okay, now this is what? This is the length of A squared, this is length of B squared, and this is the dot product of A and B. Okay, so this means, so I can say dot of product of A and B then squared. Okay, so then I can say length of A squared, length of B squared minus length of A squared, length of B squared cos squared theta, where theta is the angle between A and B. So then I can say, so I can say A squared, A length squared, B length squared common, and 1 minus cos squared theta. It will give me sine squared theta. So I can have sine squared theta. So this is equal to If I cancel square here, so this means the length is given by length of A times length of B times sine of theta. Okay, so this is what we have proved here. Okay, okay. So now, so this is also the area of the parallelogram. This can be easily seen. So if you have this A and this is B and this is your theta, then the parallelogram is something like this. And the vertical height is, you can appreciate that the vertical height is given by, so this, if this is A, this is B, this is B sine theta. Okay, so the area of the parallelogram is the base times the vertical height. So that's why it is this much. Okay, now before we finish, let's do an example here. So if we want to find an area of a triangle whose coordinates are given by 1, 1. So now we talk about in 2D. So, and then 0, 2. And the third one is 3. Okay. So your A vector is the vector joining these 2 points. So this is 0, minus 1, which is minus 1 minus I, and 2 minus 1 is plus j. And then B is the vector joining these 2 points, which is 3 minus 0 is 3i and plus 0j, correct? So A cross B, this is equal to, and then since A cross B we have defined in ijk column, so we'll say plus 0k and then plus 0k. Okay, so then this is equal to I j k, then I will say minus 1 1 0, and then I will say 3 0 0. Okay, so now if I calculate it now, so this is equal to, if I open it from this 3, so I will have minus k here, so this is equal to minus 3k. So then this means that the mod of A, or the length of A cross B, this is equal to 3, because of the absolute value of negative 3 is 3, and the area of the triangle is half of it. So half is, this is equal to 3 over 2. Okay, so that's the area of the triangle. So what we have done is we have used these three the vectors which we want to take the cross product of, and then we, in the end, once we have the cross product, we take the magnitude of that. That is the length of the cross product, but that is also the length of the parallelogram which is spanned by A and B, and half of that is the triangle which we are talking about here. Okay, so this is it about cross products. What we have done is we have showed the definition of cross product. We have talked about one identity, the triple product, and the implication of that, and then we have also shown the proof of the length, how to calculate the length of the cross product, and then one example showing how to find the triangle's area using the cross product approach. Okay, so hope it was easy to understand, and thanks for watching. Hope you liked the video.